work as an IT transformation manager. We started this blockchain meetup group a couple of years ago, and I'm a very firm believer that we all have an opportunity to support and reverberate the efforts that we're looking to do. We do a lot of random cool projects. We hosted a couple of staking nodes. We've deployed a couple of contracts, and we have a couple of really cool things on the roadmap. So we host these events to reach out to the community and see who wants to get involved. And if you do, reach out to us and let's go do some really degenerative finance stuff. It's really crazy out there.
Cool. How about you, Thomas?
My name is Tom. I'm from I live on Long Island. I've been a realtor now for starting my 19th year on this crazy Long Island real estate market. I'm not a technical guy or anything else like that, more of an investor. I've been pretty much following cryptos for a long time. And basically maybe the last couple of years more so than any other time. But just trying to learn. I think it's like, who's that? Paul Theta Jones says the fastest horse in the race right now. And hoping to be on that horse.
Awesome. Well, welcome. I guess I'll just go down the list here in the group. Felipe?
Hi, my name is Philip. I'm totally new to crypto. I'm from Canada, and I'm at the very, very early stage of learning. And when I saw that there was such community on Meetup, I said, hey, I'll just join in, listen in. I'm sorry, folks, I don't have too much to contribute, but I have a lot to learn.
Hey, when we're doing our introductions, just mention whether or not you have a MetaMask wallet, and if you do, and if you don't, you can we'll cover that. But just throw it in the chat window, and we'll be able to send some of these coins that we create.
Appreciate it.
Cool. Well, welcome. It's good to have you.
Okay.
Bob S.
Hey, this is Bob, and I work in the software industry. I do marketing, and I've been playing around with crypto for about a little over a year and a half now, and just interested in this meetup to learn about what you guys are doing.
Awesome. Well, it's good to have you. James Folk.
Hey, yeah, I am the guy with the kid that I'm putting to bed. He's laying
Cool.
next to me.
Oh, cool.
So I can't, I'm in the dark right now.
All right. We'll try to keep it down.
Yeah, well, I'm a software engineer 15 years. Right now I'm consulting for EOS.io coin. I'm interested. I wrote it in 2017. It was great. Ripple did really well at one point. I know there's ways to make coins, so I was interested to hear what you guys have to say. And I'm really I make games is really what I focus on. But working for EOS.io, I learned a lot. I'm learning a lot. So just here for the ride.
Awesome. All right, Jason Brown.
Yes, I'm Jason. I'm out of the U.S. And invested in various crypto assets. I say, because they say when you learn about gold, people that made the most is the ones that sold the picks and the shovels. So I know there's more than just Bitcoin. But invested in various assets, crypto assets.
Awesome. Welcome. Joe N.
Hi, yes. I myself, like James, also put my daughter to sleep, so I'll be kind of off air. But yeah, been into crypto for quite some time now. During the ICO phase, got in. I'm a data migration specialist for a software company for financial advisors, and just looking to increase my skills. Starting to learn Solidity, just programming on the Ethereum blockchain, and excited to be back on. I attended an event with you guys in Stony Brook a couple years back. Great event, nice group you guys have here, and excited to learn.
Awesome. Good to have you back. Raj.
Hello, hi everyone.
Hey, Raj.
I'm Raj. I work as an information security analyst and identity access management engineer. Uh, so crypto, I know a bit about crypto, but I didn't do any trading and all, but I never showed much interest. But with all the growth in the crypto, Bitcoin and all, I also wanted to learn about the blockchain technology because it's being used in other services too. So I came across this Meetup group and I thought, okay, why not just, I think this could be a best platform to learn or gather some information.
Awesome.
Nice.
Awesome.
Meet
It's
you
good to
all.
have, it's good to have you.
Thank you.
Raj, oh, this is bouncing around on me a little bit. Shamir Powell.
Hey, my name's Shamar. I'm a
Shamar.
part-time teller. And yeah, I just wanted to increase my skills by learning about blockchain, Bitcoin, Ethereum, all those cryptocurrencies. Yeah, so hopefully it could increase my career prospects.
Awesome. Awesome. Good to have you. Vignesh.
Hello, I'm Vignesh, working as a software engineer in the morning. And I'm investing in cryptocurrency for a while. I would say like maybe 6 months. So I saw this through the Nick. He posted in the Meetup. So thought of learning more about cryptocurrencies, and it's based on Long Island. So thought of getting into it and learn more about it.
Awesome. Good to have you.
Yep.
So this list is bouncing around on me. I don't think I hit everyone. If anybody else wants to introduce themselves, just kind of put it out there. You could just kind of get connected and introduce yourself.
I'll go ahead. My name is Massa, and I, like a few others here, am a complete novice to crypto, but friends have been trying to convince me to get on board. So I've become interested, and I work as a social psychologist. So, and I don't have whatever wallet Craig was referring to. So,
Cool.
Yeah, thanks.
It's good to have you.
So Nick, now seems like a good opportunity to explain what a Metamask wallet is, if you want to share your screen and show us a little bit about it.
Yeah, so today, well, first of all, just I want to thank everyone for taking their time to come out tonight and get connected with us. You know, we're trying to make this at a time that makes kind of sense for folks with kids. And hopefully, you know, I know my kids are starting to go to sleep too now. But yeah, so MetaMask is basically a wallet that runs in your browser for the Ethereum blockchain. And we're going to talk mostly about Ethereum tonight. As many of you guys probably know, there are many different types of blockchains, Ethereum being one of the more popular ones. And in many respects, it seems like the one with a lot of utility for a lot of other applications to be built on top of it. So basically what MetaMask does is, and let me go ahead and show my screen here. And you know what, I'll share my screen right through here. Okay, you guys all got my screen here?
Yep.
Okay, great. Yep. So MetaMask, maybe I gotta get this out of the way, is this little, once you install it, it's this little tiny fox icon, right? And if we go ahead and
just say
that again.
It's an app.
It's a Chrome extension.
Yep. So you can get it at metamask.io. And this is what the page looks like. It's super simple to install as a Chrome extension here. Once it's installed, I've got a ton of little Chrome extensions, so there's a bunch of icons here, but the MetaMask one is this guy right here. And when you click it, somebody else coming in. When you click it, you're going to see basically your account information, right? And you can flip between different networks. So when I say network, there's different networks that are part of the Ethereum blockchain. Basically, they're different blockchains. Some of them are test networks. There's one main network, right? The main network is where the actual contracts and accounts are. That's where the real money is. The test networks are just networks where we can just play around with technology and see what we can do with it. The different test networks implement different consensus algorithms. Some of them are proof of authority. Some of them are proof of stake. There's different types of networks and how they come together. And let me just back up for a second. As we were preparing for a lot of these talks, the base for this stuff is growing so much. The amount of different pieces to this is getting larger and larger, literally by the day. So most of the things that we talk about today can fork out into talks in and of themselves. And I'm hoping that happens here. Really, we're trying to kind of foster this community of experimentation and learning so that, you know, this talk is general enough where pretty much every single thing that we bring up, we can dive into deeper, right? And I hope to do that over the next months and probably years. So here I'm connected to the Gorelli test network. And you can see here that I have 99 ETH inside of that wallet. We're going to be using this wallet today to basically deploy a program to the Ethereum blockchain. That program is called a contract. And that contract is going to basically house information about a token that we're going to create. And then this account, this very account here, will own that token. And I plan on sharing the private key of this account with all of you today so that you can do it yourself to see what goes into actually creating a token on the Ethereum blockchain.
Nick, when you say you're sharing the private key, you have actually, this probably goes into the next subject, but you've created a test environment for us all that is sharing that one wallet. So we are all using one wallet in Nick's created environment. And through that environment, we'll be able to create any coin that we want. So Nick,
Yes.
create a coin, I'll create a coin, Thomas, you can create a coin. We can all create a coin. And for those of you that are putting your wallet addresses into the chat window, after we create it, since we're going to create it in this wallet address, we'll go ahead and send them out to everyone.
Exactly. Yep. Kind of in the vein of trying to foster a culture of experimentation here in our community. Pretty much everything we're doing today is an experiment, right? We're creating a coin together remotely over Zoom. You know, the world has been a mess for the past year or so, and we have not been able to get together. I would much rather do this in person and you know, be in a room, but that's obviously not possible right now. So I developed a tool that it's a product that I sell to schools for development, but I'm trying to figure out ways to use it for crypto, for developing crypto smart contracts. And I'm looking forward to experimenting with it today to see if we can use it to actually create these tokens. And we'll get into this in a minute once we get into the talk a little bit more, but this is something called Stack Starter. And it allows us to have a full-blown development environment directly in the browser. And I'll show that in a second when we go and spin our environments up. And again, like I said, it's an experiment. This could, you know, the demo gods could be against me and it doesn't work, but hopefully it will. I'm pretty hopeful. So we'll be distributing that in a little bit. What I'd like to do now, I think, is why don't we dive right into the talk? If anybody have any questions before we dive into, I got a couple of slides, and then we can start to get some hands-on stuff going down.
Hi, this is Tiffany. I'm totally confused. So like, I know I have a MetaMask on my phone, but I just like downloaded it. So it basically just says get started. So do I need to? Does it?
You won't need to.
Yeah, tell me.
You won't need to in order to engage with what we're doing here. You can get that set up and then you'll always have a wallet and we can send you the coins after, but you don't actually need to in order to engage with what Nick's gonna show on the screen.
Okay,
You can do the get started. It's a really easy tutorial and it'll give you, once you create that tutorial, it'll give you a wallet address. You share that wallet address on the chat window. And then we'll be able to send you stuff.
Okay, so I think I'll do it after because I'm definitely gonna not understand what's going on if I'm trying to do the get started and it's at the same time.
Totally.
Don't worry that you can't stay with the class.
Okay, yeah, I can't walk and chew gum, so I'm gonna just pay attention to you guys, and then afterwards I'll get the address thing together. Okay, Perfect. Thank you so much. So you guys know I'm Tiffany. I'm from New York. I am kind of new to this space. I know more about the crypto and the trading part of this, but I'm really interested in making an NFT and branding some of my own art and stuff. And I know this is the way to go about it. So when I saw this, I just wanted to come and check you guys out. So thank you so much.
Awesome. Thank you, Tiffany.
I would love to
Thanks for
talk
joining.
NFTs at another time, another meeting.
Yes.
Okay, make another one with the Long Island group, right? And I'll come through.
Awesome. Cool. And guys, too, while we're doing this, if there's any questions, anything, just unmute yourself and dive right in. We want to make this as collaborative as possible. So this isn't. I'm not trying to sit here and just broadcast. I want to get everyone talking, right? So if you have any questions, don't hesitate. But yeah, you're right, Tiffany. When you first install MetaMask, it's going to try to get you to create a wallet. So it's going to show you these seed phrases. You're going to have to re-enter the seed phrases. So yeah, if you don't have it installed, don't worry about it. We are recording this as well. So it may actually be a better bet if you want to come back to it. We're going to post this to liblockchain.org, and you can follow along after the fact.
This is Raj.
Hey, Raj.
I'm just trying to download and install the extension. I just got an alert saying this is just like MetaMask. It says it can read and change all your data on the websites you visit. So
The websites that you connected to, yeah.
Oh, okay. So it will read the data and also change the data.
Well, so what MetaMask does is it's a way to engage with the Ethereum protocol while you're on a website. So the website is where all of us are going to actually have a UI, be able to execute against contracts. You're doing that on the web. But what MetaMask is doing is it's calling that contract or that transaction, it's actually broadcasting it back to the Ethereum protocol. There is no, there's no web or UI for the Ethereum protocol. It's just, command line, I guess. So that's what MetaMask will do, is it needs to be able to engage with the website in order to push it back to the Ethereum protocol.
Gotcha.
Yeah, fundamentally what MetaMask does is it injects a library called web3.js into your browser. And web3.js is a JavaScript library that implements the remote procedure call interface for Ethereum nodes. So it knows how to communicate via the API to Ethereum nodes. So you could do things like sign a transaction and send it to a node, right, to be mined. So it's basically just you can think of it like an on-ramp to Web 3.0, where Web 3.0 is the Ethereum network.
Yeah, and I'm really sorry. I'm like a very beginner and into this. So when I was just trying to install it, I saw that alert. So I just wanted to ask. Okay.
No, that's a good question.
No, excellent question. Keep them coming. This is why we're here. We want to learn together. So awesome, Raj.
Thank you.
Yeah, so once you do have it installed, this is basically going to be an interface for you to transact on the Ethereum network. But you're going to see as we work through this, it's also a way for you to have other types of tokens. As some of you guys have probably used, you may have heard the term ERC20 token or altcoin. Altcoins are basically just smart contracts that are living on the Ethereum blockchain. And they allow you to keep balances within them of certain tokens that are created. And that's what we're going to do today. We're going to create our own token and show you how you can put it into your wallet and then use it like you would regular Ethereum, and pass it around the network.
Hey, Nick, I just installed that MetaMask, and there is an option for the network. So which one do I need to choose? I see Robston Test Network, Coven.
Sure, you're going to want to use Gorelli. We're using Gorelli today.
Gotcha. Okay.
Yeah, cool. Yeah, I think Gorelli is implementing some of the newer versions of the protocol. It was used for testing the staking nodes for Web 2 ETH 2.0, and it is approved.
Yeah, it's designed to be that final testing protocol. So it's like Go ETH. And it's right before the things that they deploy onto the mainnet. And keep in mind, when you deploy things on the mainnet, it's really just a hard fork. And we can talk about that stuff later.
Cool.
So
Is that the reason you chose Garelli?
No, we just, it's one of the test nets. It's one of the test nets that the ERC20 tool set that Nick was using used natively. There's no reason that we can't do it on the other networks. We just,
I know. I'm just curious of what the reasoning for picking that one.
Honestly, the reason was because the testnet faucet that gives you free ETH requires you to do like a tweet with your address in it. And I did one for the Garelli network a while ago, and I can keep reusing it. So I can keep just getting test ETH using that. So it's just mega convenient for me to get test ETH.
Do me a favor, don't find it obnoxious, but I'm curious why you originally chose it when you created it.
Yeah, so we originally chose it. We were actually, when we did this talk about a year ago, and we were on Robstein, but we moved to Garelli because we were experimenting with a staker node, and Garelli was the test net that required you to connect you to be able to stake. So yeah, that's why Garelli was chosen.
So at the time you were doing it, Garelli was the only one that was allowing you to stake?
Yep.
There was nothing else available, and now you're just using it because you had it already done it before and you already have the coins there.
Exactly. Yep.
Sorry, I'm always interested in reasoning.
Yeah, cool, no problem. And I think the confirmation times on these test nets may be slightly different. I know Garelli is, I think every 12 seconds a block is mined, so it's pretty fast. We send a transaction and within 12 seconds it will be confirmed. I think some of the other test nets may be a little slower, so that may be another reason why you would choose one over another. All right, guys. So I have a couple of slides. I'm not a big slide guy when I do talks. My slides are typically very light with information. They kind of just serve as a guide for what we're kind of discussing during the talk. So it's, maybe a dozen or so, not even slides. And what I'd really like to do in this talk is to kind of take you guys through a quick journey. We're gonna kind of really stay at the top level, and then we're going to dive into some technical details. Now, for those of you that are here that are not technical, don't worry. It's, we're not going to get crazy. We can get crazy if you want, but we're going to try to keep it pretty top level. I want to start kind of just explaining what Ethereum is fundamentally, and then we can start to kind of peel the onion back and start to dive into some of the depths of what smart contracts are, and then specifically what ERC20 tokens are. And then we're going to take a look at an implementation of that and see if we can actually create one and deploy one. So we'll see. This will probably go for about another hour or so with this, and then we can kind of just discuss it a little bit. So we already did introductions, and I don't have to go through that. Kind of went through this a little bit, what the goals of this talk are, right? We're going to introduce Ethereum. We're going to talk about smart contracts, and then we're going to get right into developing our token. So let's talk Ethereum, right? So Ethereum launched in, I think, 2015. The yellow paper was written by Vitalik Buterin, and brilliant dude. And when I first saw this, it was probably pretty early on. I was into Bitcoin, and I saw these guys coming out and saying you can write governments with it. You can write these autonomous organizations and stuff. And I thought they were absolutely insane. I did not understand it at all. And I kind of dismissed it a bit. I said, this is not going to work. This sounds like too radical for me. It's not something that I think is ever going to be a thing. I didn't last too long. And eventually, as I dug into a little bit more, I realized there were a lot of improvements on Ethereum as opposed to comparing it to Bitcoin. Really, you can think about Ethereum fundamentally, right, as a world computer. And I like to think about it like this. Unlike Bitcoin is more of a has more of a transactional utility where we could just pass around a number. Basically, we could say, I'm going to send you 1 Bitcoin and you can send me 1 Bitcoin. We could just transact. There's no concept of software executing or logic executing on Bitcoin. I think a couple of folks have tried in the blocks. There are some space for you to put maybe compiled code and pull it down and run it locally, but to many respects, that's not working. Ethereum was built and is fundamentally a computer. It's a computer that runs distributed across the internet for anybody that runs a piece of software called a node. And that node, which is just simply a piece of software, just like Zoom or the browser that we're running right now, runs on any computer around the world. It's a peer-to-peer protocol. So everybody that's running a node, just like if anybody has ever used BitTorrent or anything like that to, download movies they've already purchased, it's the same type of concept. The big difference is that with Ethereum, those nodes implement a full instruction set, right? You can think of it like a CPU on a computer. Those CPUs implement an instruction set, which is basically the raw building blocks for you to develop software and execute logic on a computer. It's what makes a computer possible, right? It's one of the key components. Ethereum does that, but in a distributed peer-to-peer piece of software that we all can run. And you can actually see that right here. This is on GitHub. These are actually the opcodes that the Ethereum piece of software, which is called the EVM. And for the developers that are on the call here, you've probably heard that with Java, right? Java runs in a JVM, and any code base that compiles to what's called bytecode would run over, on top of another piece of software that can interpret that bytecode and execute it. So you can see here that these are all of the different instructions that the Ethereum nodes can execute. Now, the interesting thing about this is every single instruction takes some type of gas. We call this gas, right? So to multiply two numbers together, it costs 5 gas. And what does gas mean? So gas, in this case, this is 5 Wei. Wei is a unit of measure for Ether. Ether is, somebody else is coming in here. Ether is basically one Wei is 1 Ether divided by 10 to like the -18th power. So it's a crazy small value, but that's where Ether comes from. Ether itself is a utility token for you to execute these instructions on nodes across the entire network of folks running the Ethereum node software. So that's where Ether comes from. It's really used to execute code. And that's why we can visualize it as a world computer. It truly is a world computer. We were able to now execute in a distributed fashion all over the world for anybody that's running the node software. Any questions there?
Can you post that link? I like that one.
Oh, yeah.
So the gas is basically a small piece of Ethereum.
Yes.
Exactly.
It's charged when you
No, gas
Anything
is
with
a
the
generic
Ethereum.
name.
like it's fee.
Like gas for your car. In order to run your car, you have to have gas. I think that comes from that. It's a generic name. In
Right.
Ethereum, it would be one thing, and in Bitcoin, it would be Satoshi's. So it doesn't have to be, it's just some small percentage of whatever the currency or whatever chain is. It's a
Right.
payment for using the chain. Like it's a toll when you go over the bridge.
Right. Yep. Exactly. And in Ethereum, it's measured in Wei, right? And we kind of multiply it up one order of magnitude. We call it G-Wei when we're looking at the cost for transactions. But this is significant because this really this is what Ethereum or Ether really represents, is your ability to execute code on the blockchain, right? By holding Ether, you're holding your computational power basically for the blockchain itself, if that makes sense. And if you wanted to dive into that a little deeper, this is how this type of technology solves something called the halting problem, which is a problem described by Alan Turing many years ago, which is, it's a basic theorem. It's kind of crazy. It basically says that one function cannot determine if another function terminates, which is kind of a crazy thing to think about. We could go more into that, but somebody say something?
Please go into that. Or I know
Sure, sure.
before or after, but go into it.
Sure. Okay. Yeah, I'll come back to that towards the end because we could go for a minute with that one. But that
I was gonna say, so is Ethereum doing proof of stake and also proof of work right now? They're
Yes.
doing-
Right now, they are primarily proof of work. They launched what's called a beacon chain for proof of stake in December. And
Right.
that's going to take at least a year before they actually are going to migrate from Ethereum 1 to Ethereum 2. And once they do the full migration, it'll be proof of stake. They are offering proof of stake rewards right now.
You have to have 32 ETH.
But it's not, there are ways to do it with less using hosting services. But it's not actually used for creating the blocks. Proof of work is actually still used for creating the blocks. Proof of stake is only there to create an
Validate.
issuance and basically test run that this will work. What
Okay.
caused the gas price to fluctuate? Demand. So right now, demand is rather low. Gas price is about 81 gwei.
No, it is low right now. It was like what 150 yesterday when we were talking, Craig.
I mean, I've done transactions as high as 700 gwei. I've seen them as high as 1,000, and it's with Ethereum going up in value so much. You know, these transactions, a simple transaction is $15. You're not going to do that for, you know, small transactions. It really becomes quite a big portion.
Yeah. And this is important too, because as we execute code, right, this 80 right here represents really the cost to do a basic transaction, right? But if we were to call into, say, something like maybe Uniswap or something that's executing code in a smart contract, that means that you are going to start executing instructions inside of a smart contract, which costs gas. So your transaction cost to do that is going to fluctuate depending on what you're trying to do on the network, right? I anticipate if it's not already happening, folks coming out with a lot of optimization techniques for code so that you could say, hey, I have this smart contract, but can I get it so that it's cheaper to execute the smart contract?
Yeah, and they'll always be doing that, but in a bigger macro level, it's getting onto layer 2 solutions.
Yeah. That's true. And that could be a whole nother talk too, right? Talking about what layer 2 is and how that's going to work.
Yeah, I need to learn more about that too.
Yeah.
I can talk on it.
All right, guys. So that's really a basic overview of Ethereum, right? There's a ton of stuff we can go into with it. It's really exciting, and I hope we can do more. Also, too, if you guys have any ideas on talks going forward as we go through this, and you guys want to put yourself out there and just kind of do a talk on it, we'll welcome you with open arms, and that would be awesome.
And just to bridge into what we're doing here, this talk of create your own crypto coin is one, to help our community and network, but two, it's Nick and I have some learning that we need to do because we will be doing a Long Island blockchain coin. Very clear, it has no financial value, but anyone that participates in our community events, we will be distributing on mainnet these Long Island blockchain coins. And the incentive here is the more that you participate and help us create this community, we'll just give you more Long Island blockchain coins. And again, they have no financial value, but neither do any of these coins when you go by the nuts and bolts of these things.
And what would be an application? What would you use it for?
Yeah,
we have a couple of ideas that maybe we'll talk about at the end, but there's, if you hold the coin, you have access to certain features on a website.
You're not going to close a meetup to people who did not hold your coin, right?
No, of course not. Absolutely not. It's really.
I just asked.
Yeah, no, it's definitely something that we're just looking to experiment with. Like, there's certain things that personally I'd like to try to implement, like what Craig just said, which there's services coming out now that instead of paying like a traditional, monthly fee or something, you just have to hold the token. And by holding the token, you get access to the service. And to me, that's mega interesting. That's like a completely different way to think about accessing stuff. And I'd love to do things like, how do you implement that, and have a, do a community event where we actually implement that to see what we would do. And we would need a token to do that. So we would, use the LIBC token.
Today we're doing it on Ropestein. Next event, we'll do it on Main.
Yeah. Well, Gorelli today, but yeah.
Yes, sorry.
All right, so that's Ethereum. So that kind of leads us naturally into, okay, so I just said it's a world computer. So a computer runs software. What type of software can you run on this world computer, right? And that's what leads us into this idea of smart contracts. And I'm sure most of you guys here have heard the term smart contract recently. And basically what a smart contract is it's a piece of code that you can execute on the blockchain. You can call into it. It has an interface just like any other, we would call an API, right? An application programming interface. So you have different functions that you can call. So you can call into a function that says, hey, I have two numbers. Here's two numbers, add them together. And it'll return back to you those two numbers added together. Really simple, right? Smart contract development right now is in fuego. There is so many exciting things that are happening in smart contract development. Really a lot pertaining to DeFi, right? Decentralized finance, being able to swap between different tokens, being able to, stake tokens and earn passive income on it. This is all things that are made possible by implementing and deploying smart contracts to the Ethereum blockchain. So really smart contracts are the, software that we're running on top of the Ethereum blockchain. And, if writing smart contracts, you could go in here and write these instructions manually, right? And you can write a smart contract and then compile it and then run it on the EVM, right? But naturally, you wouldn't do that, right? Just like as any software developers here, we wouldn't be like, yeah, I'm going to write a program. Let me just dive right into that x86 assembly code and just start typing it, right? We have tools that kind of are on top of this that allow us to develop code in a more kind of user-friendly fashion, right? The higher level languages that allow us to develop this software. And the software that we're going to look at today, the programming language is called Solidity. It's we'll show off the syntax in a little bit, but it's very much like, JavaScript. Did somebody just raise their hand? I saw a hand raise here.
I did, but you're going into some, so I'd rather you keep going and then later I'll come back. I'll circle back.
Okay, all right, no problem. So yeah, so there are a couple of different higher level programming languages that are starting to emerge. Two of them come to mind. There's probably others. Solidity, which is the one I'm most familiar with, and Viper, which is another language that's similar to Python, which kind of makes sense, right? Viper, Python, I get it. Solidity, the syntax of Solidity is a lot more like JavaScript, which there are a ton of JavaScript developers out there, right? If you're doing any type of web development, you're using JavaScript. But as you're going to see, when we are developing smart contracts, we're kind of blending a couple of different programming languages together. Specifically, what we're going to be using is JavaScript and Solidity together. We're going to be using JavaScript to coordinate our deployment, and we're going to be using Solidity to write the higher level statements that compile down into the Ethereum's EVM bytecode. So, like I said at the beginning of this talk, the base for a lot of this stuff is getting pretty wide, and there's a lot to learn here. There's a ton to learn here. So, being knowledgeable in object-oriented programming, basic programming concepts definitely come into play when we're talking about a lot of this stuff. Not to mention layering on top all of this kind of very foreign distributed kind of systems type of topics. So it can feel overwhelming at times.
Sorry, have you looked at Mike Michelson at all?
I'm sorry, what was that?
Have you looked at Tezos Michelson?
No.
Is that Tezos?
It's a Tezos smart contract language. I was just wondering.
Oh, yeah, okay, Tezos, yes. And I think that's C++, if I'm not mistaken, right?
No, it's more like maybe Haskell, but not quite. Closer to a camel.
Gotcha. So it's like a functional programming language.
Exactly.
Interesting. That's pretty cool. So that's a completely different kind of programming methodology, right? So to do it in a functional language. Be
Right,
interesting.
but then it allows you to formally verify your contracts.
Ah, interesting. That's cool. I'd be interested to see that. I'm not really too familiar with Tezos, and quite honestly, I am curious about the utility of a lot of these other blockchains that implement these types of ideas, and where do they fit into the world, right, of cryptocurrencies and just blockchains in general.
That's a fit because you can formally verify it. So it's not as hackable as anything else.
Okay. So when you say formally verify, I'm thinking like more of a static analysis tool before you deploy these things, before you deploy the smart contracts. Is that what you mean?
No, you basically prove that your specifications are followed very closely by the code and there is no discrepancies.
Okay, interesting. Yeah, I feel like there's a lot of energy now in different services around that. Like with Ethereum, a lot of these larger smart contracts that are being used a lot are going through these audit processes, right? Where they're getting audited by a bunch of different teams and they're being certified secure and stuff like that. I don't know if a lot of that is a play on just getting people to be more confident to send money into these things. But I do think that's an important aspect of this is you need to be able to verify that this is working. I do feel like that that's the biggest security hole in all of this right now is bugs in smart contracts. Some of these smart contracts literally have billions of dollars worth of value in them right now. So, that's a thing. if that can get hacked, that's a big deal.
Well, that's why
they're hacked all the time.
Yeah.
That's why the Tezos Michelson is not just another toy.
And so how does that verified contract help? Because when I say hacked, I don't actually mean they've hacked the code. Instead, they've just exploited a vulnerability that maybe they can mint a token that they didn't expect could be minted, or it could be sent, or it could be.
Once verify that the code is exactly what you specify in the first place, the vulnerabilities, are less likely, unless you did wrong specification to begin with.
Yeah, you don't know what you don't know until it.
Right. I posted the link if you're interested in taking a look.
Yeah.
Yeah.
Well. Cool. So
Michelson is literally called the language. Awesome. This is really cool. Awesome.
I was asking you, I'm sorry.
Yeah, excellent. Cool.
You're up for our Tezos talk next.
Yeah, right. I think you just volunteered yourself.
I hope not. I'm not that good. I'm mostly asked questions.
That's cool. Thank you.
Sorry.
Oh, could I just ask something?
Sure.
So you said Viper was like it's similar to Python. So what makes it like that? Because Python's like the only language I know. I know like the bare minimum.
Yeah, sure.
But what makes it like that?
So I think that Viper is a lot like Python in the respects of its syntax. Like Python is white space oriented, right? So you have to make sure that you space your code properly. If you don't space your code properly, it'll break. That's unlike things like JavaScript where you can, it's more of a free format where you can kind of put everything in curly brackets and things like that. So I think the similarities from what I understand, definitely not very familiar with Viper, but are really along the lines of the syntax.
Okay, cool.
Yeah. All right, cool. So that's basically kind of the brief overview of smart contracts, right? Thinking about it in terms of this is the code that we now can run on this world computer, which is really powerful. Now, if we hone in on that concept a little bit more, right, we get a little more detailed, that's when we start to look at tokens, right? What are tokens? What about tokens? So tokens are just a specific type of implementation of a smart contract. That's all they are. So a token is basically a smart contract sitting out there on the blockchain. And that smart contract can have information inside of it, functions that you can call, right? That API interface for you to actually interact with the code. So a token really is just basically a smart contract. And it's pretty amazing how simple the token concept is, right? If we think about a really simple program, right? A program that has a function, say, we'll call the function main. And inside that function, we define an integer value called myInteger, right? And that integer value maybe just outputs to the screen, right? That integer value can represent the balance of a token. It's just managing a number inside of that main function. That's exactly what a token is. A token is just really a contract that is managing the balance of a number, right? For different addresses. So we could say my address has 100, your address has 500, et cetera, et cetera. That's really all it is. And then we have a little string value that says what is the name of this token? What do we call this integer value? Or you can call it LIBC or Long Island blockchain token, whatever we want to call it. But that's what it is. There's nothing there that says, hey, give this value. We have to give it value, right? We have to actually, as a marketplace, give it value. And that's where some of these really interesting decentralized finance ideas come into play that are just seem to be emerging all over the place with, staking and stuff like that to provide value, adding liquidity of a token to Uniswap. And then all of a sudden you've created this token that has value, which is just amazing to me. So that's really what a token is fundamentally. And we're gonna see it a little bit deeper as we dive into the actual code. So let's see what we got next. So in order for us now to get a little bit more specific, right? So we talked about a token, we talked about managing a single value, some integer value. But in order for us to have any kind of interoperability between different tokens, we need to have a standard that everyone follows. If I implement a token that has function A, B, and C, and I deploy it, it'll work for anybody that knows how to coordinate their calls into that token by calling A, B, and C. But if Craig goes out there and mints his own token that has functions X, Y, and Z, those two tokens really can't play well together. And specifically, things like wallets here, like the Metamask wallet here, will not know, I shouldn't say not know, but it'll be more challenging for the implementers of this wallet to say, hey, I know how to communicate or exchange or transact with the Long Island blockchain token or the NIC token, but I don't know how to communicate with the Craig token because they're two completely different implementations that are solving the same exact thing.
Are you talking ERC20 tokens there, Nick? Because the way that that transaction would work is it doesn't matter what it's called. If you call it for LIBC token and then I call another one LIBC token, the Ethereum network doesn't care that they're both called LIBC tokens.
No, it's
two
not
separate hashes.
It's not the name that matters. It's the interface that we're using to call into the actual tokens. So if anybody here that's is knowledgeable about object-oriented programming, that the word interface probably rings a bell. An interface is just basically, the way I like to put it is, and maybe it's not the best for blockchain stuff, is it's a contract that you have to abide by when you implement a class or a piece of code. So if I say that a token needs to have a get balance function and a set balance function, in order for me to be ERC20 compliant, I need to implement those two functions. If I deviate from that, it's not an ERC20 token. I could deviate from that and it would work for me, but all the other folks out there that don't know about my token will not be able to talk to my token at all.
You're talking about the standard.
The standard. It's a standard interface for developing tokens. Without that standard, it would be all over the place. And that kind of, we can step back even further and look at how that works on the internet as a whole, right? The internet works because of these types of standard interfaces, right? If you think about like TCP/IP, right? If everyone used a different transport technology to connect to the internet would be a mess. It would be horrible to work with, right? If everyone used a different routing layer than IP, it'd be hard to work with. we'd have to have all this other software and hardware to coordinate all of the traffic that's going all over the place. So this is what's happening in Ethereum. We have these standards that are emerging, and these are literally emerging, right? There's already been some improvements made on ERC20. I think it's called ERC777 that implement a couple of additional function calls that have some other functionality tied to them. But yeah, so the name doesn't matter. It's really that how it's developed is what matters, the structure of that code.
Is this, quick question, is this why they've built out things like Polkadot and things that are dApps that can speak to other chains? Or am I getting this mixed up? Chainlink or?
Well, Polkadot is different than Chainlink, both really cool projects. Polkadot is meant to treat each chain as a side chain that it's meant to talk back to Polkadot as the master chain.
Gotcha.
Chainlink, on the other hand, is a consolidation of various data points, a trustless consolidation of all these data points, and then other callers call into it with the random zero knowledge proof factor, and another topic that we'd have to go into of exactly how Chainlink works. But that's what's called an oracle. It's just grabbing data points. Now those data points can exist on the Ethereum network. They can exist on Bitcoin networks. They can exist on Tezos networks. They're just, the consolidated data points for Chainlink.
Gotcha. Okay. Just trying to apply what you're saying to what I know and make sense of stuff. Okay. Thank you.
Cool. Yeah. And Chainlink actually, I believe is the concepts here are consistent, because Chainlink is really taking data as an input. So we can publish, data to Chainlink, and then Chainlink exposes it in a standard interface that others can then consume. So going back to that standard interface, that's really the key point here is being able to expose functionality in a standard way that allows us now as developers of this technology to kind of snap things together like Legos, right?
Gotcha. Follow. Thank you.
Cool.
So how does Quantum fall into place? Is Quantum more along those lines? Is Quantum like Chainlink, or is that different?
I'm not familiar with Quantum.
That's the QTUM coin.
From what I hear, it's supposed to connect Bitcoin to Ethereum. I'm not sure.
Yeah, I know it's built on the Bitcoin.
Chainlink does not connect anything to anything. It just provides an ability to bring the real world onto the chain.
Right.
Yeah, it's an aggregator of data points. But Quantum, I think they built that on. It's not an Ethereum token by nature.
So it's a separate blockchain that's bringing the two blockchains together.
I can't speak well enough to it. I think it's somewhere on the Bitcoin protocol.
Interesting.
But I truly don't know enough about it. Honestly, my experience usually stays within Ethereum because there's so much to learn there.
Okay.
Yeah. All right, cool. So in order to create these tokens, right, in order to actually stick to the standard, there has been a bunch of tooling that has emerged over time. Actually, you know what? I have some stats here. I just updated this slide too, because we did this talk over a year ago now, and this was at, I think, around 100,000 tokens. Now, if you look at Etherscan, there are Overwatch. It's probably higher than we looked the other day. There's about 355,000 tokens on the Ethereum blockchain right now, which is kind of amazing. So what's that?
Staking.
No, these are just not even staking. These are smart contracts that are implementing the ERC20 standard.
Oh, wow.
Yeah, so you get things like Tether, Chainlink, Binance Coin, all these guys. These are just implementing pretty much the code we're about to look at.
All smart contracts.
All smart contracts. Every single one of these bad boys.
There's nothing different than what those tokens are and the token that you will create in 20 minutes. You can BNB coin. It would have a different hash address, but it would be the exact same coin. This would just be accepted and widely used, and yours would be just us, 17 of us.
It looks like quantum is the same to Bitcoin as Ethereum to Ethereum.
Well, I don't know about that because Ethereum, to like you have Ethereum Classic. Ethereum Classic is immutable, and Ethereum is mutable. I don't, so I'm not quite understanding that.
Every blockchain is immutable. I have never heard of a blockchain that is mutable.
Well, from my understanding, Ethereum Classic is immutable, and that's why Ethereum was created because of the DAO hack, and that way they can roll back. So it's not.
No. We can go into that. So when immutable is by nature, that a blockchain is immutable by nature. It is a stack of data points, and it is immutable because you can't change one data point without changing all the previous data points. Now, what you're talking about, the Ethereum Classic fork, they made it mutable. I don't think that's a word, but they changed the they changed the protocol by creating a separate protocol. They cloned it, created a separate protocol, and said, hey, that DAO hack, we're going to pretend that didn't happen. Now, that's a whole different story of whether or not they should have ever done that. But at the time, they had the ability to do it, and they took the opportunity. They rolled back a transaction that took place.
Oh,
And they can only do that because everyone else accepted that change.
Yeah.
Or at
That's
least the majority of the people accepted that change.
Everyone except the people still using ETC.
So that sounds like how 51% of miners can alter the amount of Bitcoin that can be printed.
Exactly the case, yes. So when a 51% attack is happening, it's because there is 51% of the hash power or transaction power saying this transaction didn't take place, this one did. And I can prove that this is the right transaction versus this not the right transaction because I have more votes over here. People have voted for this more, therefore it becomes the truth.
But I don't think 51% of miners can change the number of coins that Bitcoin can have. I think that's pretty solid.
No, they can't do that. They can reverse transactions. If they had enough hash power, they can make transactions happen that didn't happen, or reverse transactions that did happen, or write any of those codes. But we're talking about an extremely unlikely scenario where they'd have to spend billions of dollars in computing power. I don't even think there were done that says there's not even enough computing power on the world to 51% attack Bitcoin right now.
Really? That's a great news. That means no government can reverse it. Thank you.
No, what I think will happen, if government wants to attack it, a government can just start buying it.
Right. Suck it all up.
Yeah. If I as a government own 80% of Bitcoin, I'm just going to say, hey, the 20% of you that are still using it, I say it has no value. I have all the rest of them. Those have no value. But again, we're talking about, fantastical worlds, who knows how that plays out.
They would bid that up to the moon, though. That'd be great for us as investors.
You hold the original one. Like, I got my one. Government can get this from my cold dead hands.
Yeah.
Craig, your mic is going in and out. Sometimes it's very hard to hear.
Oh, I'm sorry. I think I put my hands over the microphone.
well, that's what got me concerned. Maybe with all these big institutions getting into it, they buy it all up and then they all get together and they decide, you know what, let's just crush it and make it zero.
Yeah.
And we'll take a hit for 500 million.
But Craig just gave us a great news. There is not enough computing power in the world.
No, that's the
But
change.
there's enough money for them to buy it.
You own it all, and you all get together and say, you know what, let's all invest $1 billion, because to them, they're just supposedly just getting their toes in. They could spend 500 million, 600, 700 million. That's just like a drop in the bucket.
Not enough. That's not enough to crack the Bitcoin at this point. It's too expensive.
Correct.
I haven't looked at market capitalization. But
Well,
I
you know,
think
that might be a good argument for the price going up then. It protects it, right? If it goes up where governments literally couldn't buy it because it's too expensive to buy the entire network, that protects the network, doesn't it?
I'm waiting
just
for it
sounds
to
like
be.
even if all financial institutions get together, it doesn't sound like they can do it anymore. It's too late now, right?
Well, what is the total market cap of Bitcoin right now?
No, that's what I was wondering.
That's easy enough.
Yeah, what is that?
750 billion. So
So it's buyable right now, right? By us, American.
But the more they buy, the more it drives it up, and then it's a race.
Yeah.
But again, none of these are scenarios that could happen anytime soon. You know, this tech.
Well, I have to be honest. I've heard that, but I'm like really confused because I just want to like really understand this, like the whole concept, because I was told that if 51% of the people that are mining decided that they would like to have more Bitcoins created, that's how it could happen. It could, instead of be 21 million, it could be like 35 million.
Yeah, so I think we're really kind of talking about two different things here. So the 51% attack is if 51% of the miners on the network coordinate themselves together, and then they can change the protocol of the software itself. And
change the transactions that took place.
Yeah, they can change history. They can change how it works fundamentally, right? That, because if they come together and say, all right, now the nodes are going to implement this interface. I want this function call to work. They could do that, and they could say, we agree on it, and we'll use it. That is a security risk, right, of the entire network. But that's not buying up all of the currency that's on the current network to control the network, right?
So I'm more concerned about the 51% of miners thing, because people say, well, that will never happen. Why would that happen? But at the same time, I'm hearing that the mining is becoming more and more centralized. And then one day, it may not be in our lifetime, I don't know when it's supposed to be exactly, but there'll be no more Bitcoins ever created. So then miners are not going to be getting paid by mining. So isn't that a good time when they'll decide to say, hey, let's make more Bitcoin? Or if someone decided to buy, I don't know, 80% of the Bitcoin, they're saying there's no more Bitcoin left. Well, maybe we should create more Bitcoin, because that seems like what the dollar did.
You can't.
You're right.
You can't make it.
But the dollar had a U.S. government to say, hey, we're going to do that.
We're going to print it
as a decentralized consensus mechanism.
So we can call them the Bitcoin miner government.
But that's not my point. My point is it's too decentralized.
But they're saying it's becoming more and more centralized. Like, again, I'm trying to think about what 100 years, let's say Bitcoin lasts 100 years from now. So like, how would things look 100 years from now? Then not today. Like, again, it probably won't affect us. We're in the beginning stages, so everything's a bull for us.
Yeah.
But I mean, like, what about like 100 years?
Yeah, you are attacking a good point about Bitcoin. It's something that, you know, I also believe. So as far as what you called out on when will it stop creating Bitcoin, I think it actually stops creating new Bitcoins in the year 2040 or something like that.
2140. I just looked it up. It's 2140.
2140. Wow.
Yeah.
Okay, so in our lifetime.
That makes more sense.
Not in our lifetime.
And the
old.
hope for a lot of people that say, okay, well, when you stop creating new Bitcoin, well, then the transaction fees are going to have to support the miners. But the economics of that don't make sense. So we're talking about 150 years from now. You know,
it's
30 years old.
Bitcoin is it's very expensive to run. It's not going to last. It's just the beginning. Everybody's like falling into Bitcoin right now because word of mouth, and it's just FOMO.
Because they have the precedence, and that's the
the first.
They were first, and they have the acceptance across all of the institutions. They got made, you know, they have a ton of money now. By that I mean the miners that have been mining it have made a ton of money, and they've gathered enough
it's a crap technology though.
Anytime soon.
It's not going anywhere, but it's a crap technology.
Yeah, like that's a good question. Like we're focused a lot on Ethereum. Ethereum very clearly is making a lot of improvements. We got 2.0. We've got all these different technologies being built on top of it. I haven't really looked at Bitcoin at all. Like, is the software improving over time? Is the nodes that people are running getting better?
Yes, they are making it more secure, but you know, you can only shine a rock so much. Bitcoin only does one thing.
It's
21 million
right.
coins.
It's very expensive to do anything, to make a transaction. It costs a lot of electricity in a world where
yeah.
Much
What's that,
cheaper
Maria?
than to make a gas. Well, now it's cheaper. I just saw
Yes.
transaction. Ethereum transactions are even more expensive. Well, I don't know now. They change, but
I think the cost, James, you were talking about is the cost for proof of work, right?
yeah, all the miners are checking.
To create the blocks. And yes, that, I mean, it is a significant vulnerability of the technology. There are people that believe that you have to put in something to get something out, but you know, I believe in the Ethereum perspective, because they recognize, well, that's just waste. No matter how much you rationalize it, you are burning electricity just to prove that you're not robbing the bank.
Yeah, it's antiquated. It's not a very smart, not very smart way of doing it. I have some miners.
Incredibly smart. It was so innovative. Are you kidding me?
No. I mean, all right. So it's like me saying computers aren't smart. It's out of context. What I'm saying is that it's new. It's old.
It's
very
a challenge
old
to scale.
Yeah.
Right. There's smarter ways of doing it, I guess. So it's very old. There's many things that are going to come that are going to make it better. That are better than that. But
when you know, and I know we're going into the Bitcoin protocol, but when Satoshi first created the proof of work, it was obviously done on his, you know, lower level computing. You know, it was done on his personal PC. And over the years, and this is the concept of the hash power, the more intricate the equipment gets and that ability to solve that mathematical equation, the harder that equation gets. So it's an arms race, which is why they are in ASIC mining right now for Bitcoin. And what an ASIC is someone can
application specific.
Thank you.
Processor or something like that.
Yeah, but it runs a math problem incredibly quickly over and over and over. And, you know, that is not what Satoshi had when he first deployed Bitcoin as a protocol.
Mm-hmm.
So, yeah, I mean.
Yeah, I mean, I think it was
the future of Bitcoin probably, you know.
It was insanely innovative and just mind blowing when that white paper came out, and just it cracked open so many ideas that folks like Vitalik Buterin took and said, hey, we can make this better. And they developed things like Ethereum, right? And I think we're going to continue to see that.
Actually, he was trying to improve the Bitcoin. He suggested to the Bitcoin Foundation that he would like to have smart contracts on a.
And everyone told him that he's crazy.
He said no. Yeah.
They didn't say that he's crazy. They said
go back to writing articles.
No, yeah. Security for us is more important than improvements. They made a choice on the security, and I don't know that it was the wrong choice. Do you?
Yeah, that's a really interesting debate there, because in one respect, I completely can see that, right? Running arbitrary code on nodes across the world is right off the bat. So, that's a security. There's stuff that can go wrong there.
Yeah, no, I can't say that they made the wrong decision. Bitcoin is Bitcoin, and Ethereum is Ethereum now. But I've always been a believer that Ethereum can do what Bitcoin can do. Bitcoin can't do what Ethereum can do.
Right.
Yep.
I agree with you, but is Ethereum as safe as Bitcoin? As we know, through the hard forks and you know, a few variations of Ethereum now, it's not.
If we want to, you know, compare the security, I don't think the hard fork, which took place, you know, a year after it's, you know, Ethereum, or a year and a half after Ethereum was created, is on the same level of, you know, Bitcoin has been rolled back and hacked in its very, very early days, but Ethereum's, you know, rollback of the DAO, which probably was a mistake, and they self-admitted that, you know, they admitted it was probably a mistake. But as we grow with the network, the security gets exponentially higher.
Yeah. All right, guys, why don't we why don't we continue here? We've got a couple of more slides, and I want to get into some of the meat and
Let's
potatoes.
create a coin. That was the whole point.
Yeah. So we have a bunch of ERC20 tokens on the network today, right? So let's get a little technical here, and this is part of the like I said in the beginning, everything in this talk is an experiment, including the slide technology that I'm using to present this. So this slide technology is a web-based technology. It's written in React.js, which is a JavaScript framework. It allows us to do things like this. So what we're going to do is we're going to look at what a smart contract actually looks like through the code. And this slide technology is going to let me kind of scroll through the functions at a very high level. So I'm going to dive into this code a little bit more in the editor, but in order for us to implement an ERC20 token, there are 6 mandatory functions that we need to implement. Now, if you recall, going back to the idea of an interface, or we can call it a protocol too, right? Something that we are obligated to implement if we want to create an ERC20 token. There are 6 things that we are obligated to do. The first is to have this total supply function. This total supply function is going to return to anybody that calls it how many tokens actually exist. So when we create our token, we can say, hey, I want to mint 10,000 tokens, 100 million tokens, 1 billion tokens, whatever I want to create. This total supply call will return that number back to anybody that calls it. We also need some type of balance of function. Now, the balance of function is going to take as a parameter here an address, could be anybody's address, and it's going to return to them the balance of the token for that address. So instead of the total supply, now we're having the total balance for anybody that holds these tokens. So you can think of this as like the user account, if you will, of the person that has that token. Now, both of these functions, total supply and balance of, are what we call view functions in Solidity. These do not cost any gas to call. We can call these for free because they do not change any state inside of the contract itself. Nothing changes. We're just viewing things. Think of it like looking in the window and be like, hey, what's going on in there, right? We're not changing anything. And if we're not changing anything, it's free to make those calls. We also have a transfer function. Now, the transfer function does change things. So this is going to cost a transaction fee to actually transact with this. So you give it a receipt and the amount that you want to send, and then you can transfer that token, whatever the amount is, to the recipient that's declared here. All right? You can call right into that and send it. It returns a true or false value, depending if it's succeeded or failed. Now we have the approve function, which this gets a little bit interesting, and I'm still really curious about some of the applications that are being built on top of this, where you could say, hey, I'm approving another address to spend my balance. And I think this gets really interesting where an address, and we actually have another talk that's a little more into just Ethereum basically, is address can be a user just wallet address, which just has a balance. Or more interestingly, it could be an address of a smart contract itself. So you can approve a smart contract to spend the balance of your token. Now that smart contract can then be a complete program in and of itself that spends your balance using some algorithm or some rule set, right? And that's, creativity abounds there. We can think up of a bunch of different ways how a smart contract may be like, okay, it's now time for me to send a certain amount of this person's token to another address, right? Now we also have a transfer from, which it's another transfer function that allows us to transfer from one address to another address, given an amount. Of course, you would have to be approved for whatever the sender address is for this to actually execute. So the flow would be you call approve, that whoever owns the tokens, you call approve, and then whoever now is approved to, they can call transfer from to make that transfer. And I think I just looped. Did I just loop? Yes, I did just loop. So those are the 6 functions that are mandatory for an ERC20. And now the code that we're looking at here, this is called Solidity. This is what Solidity looks like. And for those that did somebody have a question? Okay, so there are also 3 optional functions that we can implement. You may have noticed there was nothing in there that said anything about the name of our token or anything like that. there are 3 optional functions where we can return a name. So we can give it like a human readable name, like Long Island blockchain token. We can also give it a symbol. So the symbol is going to be like LIBC or whatever kind of small acronym that you'd want to call it, like the ticker symbol of a stock, if you will. And how many decimals does it have? Now, Ethereum, I think the standard that's emerging now, and you'll see in a moment that the framework that we use kind of hard-coded this in a way, is to match what Ether is. Now, Ether is 18 decimals, right? You can make it so it's not 18 decimals, but it makes it confusing when you do this implementation, because now you're having to convert between these 2 values, and that becomes very messy. So it's pretty good practice to make your decimals 18, which matches Ether. So you don't have to worry about, doing all that weird math.
The computation, yeah.
Yeah.
What is Bitcoin? 8 decimals, correct?
You know what? I'm not sure. Is it 8 decimals? Anybody know that?
Yeah, it's 8 decimals.
8.
What are 8 decimals? Like 100 billion or something? I don't know.
Yeah, it's a lot.
What would 18 decimals be?
It's like, it's I don't know the actual word for it.
Sorry.
Yeah. See, 10 to the 18th.
They probably don't even give it a name.
Snake eyes, it says here. 10 to the 18th. 1 quintillionth.
All right, there it is. Quintillionth. So if you one quintillion.
It costs 3 quintillionth of an Ether to send some of those command lines that you were showing us.
3 quintillions.
That's amazing. Wow, the probability of rolling snake eyes 10 times in a row on a pair of fair dice is about that. That's amazing.
Snake eyes 10 times in a row. Wow.
Interesting.
Right. Hey, that was quick. You looked that up quick. Did good.
So in order to make this a reality and actually get this done, there are a couple of tools that we need to use. You don't need to use these. There's a bunch of tooling that comes up. These are the guys that seem to be emerging as kind of the leaders here. Truffle is one of them. Truffle is something that basically gives us a test blockchain. We're not going to actually be using the test blockchain today. We're going to go right to a public test net, but you can run a local blockchain on your computer and it'll give you a wallet with 100 Ether in it, and you could just play around with it locally, and you can destroy it, spin it back up. That's one of the tools that Truffle exposes. Truffle itself is the actual framework for what we're going to do to deploy stuff. Ganache is the blockchain locally, and there's something called Drizzle for developing the front end. I gotta love the names that these guys come up with. So we're going to be looking at Truffle today, and the environments that we've created have Truffle installed. And you'll see how it enables us to pretty quickly, using JavaScript, declare different networks we can deploy to. It allows us to compile our contracts. It interfaces with the compiler. The compiler is called Sol-C, which is the Solidity compiler. And we'll see that in a minute. Now, Ganache, as I said, Ganache is the local blockchain. We're not going to really use that today. And the third thing is Open Zeppelin. And this one is really interesting. Open Zeppelin is a framework for building smart contracts. So you can think of it as like bringing a big toolbox right to your table that has a bunch of boilerplate code that you don't have to write by just using these guys. And now one of the big benefits that I'm seeing from using these types of tools is that their base contracts are audited already. And other very, very large projects are using them on the public blockchain. So, going back to that idea of the biggest security hole on Ethereum right now is the fact that smart contracts can have security holes in them. By using code like this, there's a lot of eyeballs on it, and there's a lot of people using it. So it's not something that we're just cooking up ourselves and putting out there and hoping that it's secure. It's kind of a battle-tested type of environment. So that doesn't mean that it's 100% secure and there's no problems with it. It just, I think, lessens the probability, especially for, getting something to market. right? And it allows us to get to market quicker, right? We've got kind of a base to work off of.
And what do they charge you, Ethereum, to do this?
No, this is an open source library. So it's a GPL library. It's on GitHub. It's fully free. They're building a business a lot like a lot of these open source technologies, even outside of the blockchain space, where they wrap services around this code base. So they do things like code audits and stuff like that. I think they're doing some training. So they're building a business really around this code base, but the code base itself is free.
Wow.
Yeah, and you can go right to it. It's right on GitHub here, and I think the license, I think it's GPL, the MIT license, which is another very open license. You can use it for commercial use. You can modify. You can distribute it. They just don't have any liability. So if you deploy this, you put $1 billion into it, and you lose it all, you can't sue them.
Yeah.
So that is Open Zeppelin. That's what we're going to be using for these environments. Okay, so now let's see if this works. Now, you guys don't have to play along with me with this. It may be easier to just kind of watch this, and then I'm going to keep this available after this. If you guys want to go in there, play around with this, more power to you. I'd love to see you guys do that. Quite honestly, I would appreciate it if you just test it, because I am testing a new editor experience on this that I'd really hope it works. And if it does, I'm going to use it as the kind of the base product. So what I did was, if we go to this address here, app.stackstarter.spin, and I'll go ahead and put this in the chat. Yeah, I'm going to drop this right in the chat right here. That should take us to this page. Okay. Now, this is StackStarter. This is a tool that I wrote. It's a product that we wrote that allows us to distribute development environments very quickly. I do a lot of training. We do, I teach in a school, but I also do a lot of professional development training for different organizations. And one big issue that I found was getting into a classroom and being like, okay, guys, do you have your web server configured? Do you have your scripting language installed? Do you have your database connected to your scripting language? And half the room would be like, yeah, I'm ready to go. And then half the room wouldn't. And for a lot of the professional development training, it's one day long. We're talking 8 hours of time that I'm trying to train, a semester, or really in some cases years worth of knowledge that we're trying to transfer. And it was very frustrating, especially if you're paying for that. So it's just something that solves that problem. We kind of can just distribute the environments, and everyone has the tools. So we wrap this around this idea of a spin code. And the spin code is a lot like a Wi-Fi access code, right? When you get into a meetup or something like that, you're like, wait, what's the Wi-Fi password? This is the Wi-Fi access code for your entire development environment. So I'm going to go ahead and spin a new environment up here. The spin code for today is LI blockchain. And I'm going to create just a new account here. Just going to put a test account in here. I think I do have some password requirements. It's got to be at least 6 characters. And if we click spin up here, this will spin up a full environment. It's going to also have, it's going to have the link to the slides, right? So this will link out right to the slides that we're using today. And it's going to have this link here for build. Now, if we click build, it's going to take us out into a new tab, and it will execute an editor. So this is an editor experience. So anybody that's not familiar with development, an editor basically is just a text editor. That's really all it is. It's going to enable us to edit text like Microsoft Word. This editor is very similar to a popular one called VS Code. The only difference is it's running directly in the browser. So if I click this little icon up here, it's going to show us the file explorer. Now, I've pre-populated this environment with the code that we need to be able to create a contract. And if anybody here is familiar with Node.js development or JavaScript development on the kind of the server side, this will look very similar. And even front-end development. We're using NPM, which is a package manager that allows us to bring in the different dependencies for our project. And you'll see here that we are using Open Zeppelin, the Open Zeppelin contracts, and we're using some of the Truffle tools to be able to create our wallets. So this is all pre-populated. There's really nothing we need to do here except just kind of explore it and talk about it. So we also, too, we're going to need this. We do have an integrated terminal. So if you go up to terminal and go to new terminal, that's going to open up a command line. Now, for those of you that are not familiar with the command line, it's okay. right? I know a lot of folks like, well, command line, I'm out of here, I'm tuning out. We're not going to be doing a ton of command line stuff here. I do advocate that you learn how to use a command line if you're interested in this stuff, because it's mega useful. And it really unlocks a lot of superpowers in terms of being able to navigate an operating system and all the tools that you can kind of use with it. So here we're kind of looking at the file system just as we would here in this browser right here. It's the same exact view, just in a kind of a different way. And basically, this is the basic code base for a smart contract. Now, this is following the structure of Truffle. So what I did here is I literally just used the tool that's pre-installed here called Truffle. I think I can just go Truffle help, and that will show me stuff. Let's see. Yeah. So Truffle help will show us what this tool does. And this is a command line tool. So it's a development framework for Ethereum, as it says here. And this is going to allow us to interact with this code base. Now, why don't we go ahead and dive right in and take a look at what a contract would look like. So if I open up this contract and I go to mytoken.sol and I open this up, this right here, all 17 glorious lines of this code is all that is needed in order to create an ERC20 token. Now, I'm lying to you slightly because we're using the Open Zeppelin framework. So I am bringing in the Open Zeppelin framework up here when we say import, right? I'm saying import the ERC20 token right here and import this ERC20 burnable.sol. So I am linking in other code into this contract, but if anybody's familiar with object-oriented programming, this is going to look very, very, very similar. This is basically just an object. Instead of saying object, we're saying, or class, I should say, we're saying contract. And we are extending, or actually we're not extending, we're implementing two interfaces. So these two interfaces is what we're implementing. And actually, I'm sorry, we are extending here. The is throwing me off a little bit. These are already implemented. I'll pull them up in a minute. And then all we're doing here is we're creating a constructor, and then we're calling the constructor, or two functions of these ERC20 and ERC20 burnable tokens. Now, the only line that we would have.
Can I ask a quick question?
Yeah,
Is it possible to open up to, it's so small.
Oh yeah, you want me to zoom it in a little bit?
Yes.
There we go.
Thank you. Sorry about that.
No, thanks for bringing that up. Awesome. I always forget about that. I'm like, oh yeah, let's go. And it's like microscopic. Is that big enough for you guys?
Yeah, that's good.
That's good. All right, cool. Okay. So now this line right here, line 15, this is really where the magic happens, right? This is where we're saying, hey, the message sender. So this is an object that stores the address of the person that's sending or mining this contract onto the blockchain. So in this case, it's going to be us. We're going to, the wallet that we create, we're sending up to here. And now we're saying mint 10,000 of these tokens and store them in this sender wallet. So once we send this token up, once we send this contract up, it will be mined, and then the address that's returned to us is going to have 10,000 of these tokens within it. Now you'll see here, because we have our decimals at 18, I did have to multiply it by 10 to the 18th power. It's the only kind of bit of little math there we had to do to be able to just mine the 10,000. So you can change this number depending on how many tokens you want to create when you're creating your token. So one thing to notice here is I didn't name the token at all. I didn't name anything. We're literally defining a template. We can use this contract to mine thousands of different tokens and create all these different tokens. We don't have to change anything. And I'll go into that in a minute. That's where kind of some of the Truffle tools will come into play, and some of the JavaScript will come into play. But before I do that, I do want to show off some of this Open Zeppelin stuff, because the Open Zeppelin stuff really enables us to build or stand on the top of giants, right? We can kind of use what was already implemented. So if I dive into this node modules directory here, and I go into OpenZeppelin, expand this, this is where you can see the OpenZeppelin project. And there's one folder here called contracts. If we extend this, you're going to see there's a bunch of code here. And if we expand the token one, here's a whole bunch of tokens. So you've got ERC20, which is what we're using. And if we go into the ERC20.sol, you'll see here, and you know what? I have to get code highlighting working in these environments for solidity because I can't stand just all white text. Makes it a little harder to read. But you can see here that this is a lot larger than what we were looking at in our simple little token here. But we are using all of this code. Now this code, as you can see here, like here's our transfer from function. This code implements those 6 functions that I showed off in that previous slide. So all of that is already created for us. So we don't have to implement that, right? And there are a ton of things to explore. I think Tiffany, you mentioned the NFTs. NFTs are right here, ERC721. So if you wanted to create some 721 tokens, we could do that using the OpenZeppelin contracts. We can just extend off of this ERC721. And I would love to do a talk on that too, like similar to this, where we could just go into and see what would an NFT look like. So this is, there's a lot to explore within this. I'm not going to go through this code, too in depth, but it's basically the key point there is that we are extending off of these base contracts to be able to simply define a simple contract with the amount of tokens we want to create. Now, that's all well and good, but how do we get this bad boy into some usable state? How do we deploy this and get it onto a network? So that's where this truffle config file comes in, this truffleconfig.js. Now, truffleconfig.js, this is a JavaScript file. So we're bouncing around between programming languages. We were just in Solidity, now we're in JavaScript. The code may look slightly similar. It's going to be colored now because this editor understands JavaScript, but this is now going to load up a wallet in the code, and it's going to load it by loading this mnemonic. I can never pronounce that, mnemonic, from the file system. So it's looking for this .secret file. And this is just the way we've designed this. You don't have to do it this way, but this is going to load up the mnemonic from the file system and then use that to create the wallet that will then send out to the network. Now, I'm going to do that with you guys here today. I'm going to show you this mnemonic, and I'm going to use the mnemonic that's in this wallet here. So this has 99 Ether in it. Now, I do want to put this out there. Never do what I'm doing with actual Ether. This is highly insecure. And if anybody's on this call, if I had actual Ether on the mainnet in here, it would be stolen instantaneously because you have full access to this wallet, what I'm about to do. So you can use this wallet if you'd like, just to do this. I would just ask, be a good community member and don't drain the wallet of all the Ether, because that would be kind of mean to do. And then nobody can actually use it and it'll just be useless. But do not do this, publicly with anything that has actual real Ether in it. Also, never commit these mnemonics, which I'm about to show you, into a code base. I made this mistake the first time I did this talk. I have this code base on GitHub, right? And this .secret file, I committed to the code base, and the .secret file had my mnemonic in it, and that mnemonic had real ETH in it. I had about $100 of real ETH in it, and I think I was on the phone with you, Craig, when this happened, and I'm
drained.
Yeah, watching my wallet get drained. I'm like, I think I just got hacked. I'm like, MetaMask must have a security hole in it. I just Ether's just coming out of my wallet. What's going on? And of course, I'm doing searches on Google, and everyone's just basically saying you're screwed. You're not getting it back. And then I realized that I committed this file to GitHub, and there are automated programs on GitHub crawling the crap out of it, waiting for people like me to make a mistake and commit that to a public code repo. And that's exactly what they did. And they drained it pretty instantaneously. So just
which is why we changed the structure of how we're deploying.
Yes. Which is why we're like, we don't want anybody putting any of their own mnemonics in here. We'll just share this one publicly with you guys. you know, if it gets drained, it gets drained. It's okay. So when you're in MetaMask, what I want to do is I want to actually get the mnemonic for this wallet. So I'm going to go ahead and go up here. I'm going to go to settings, and I'm going to go to security and privacy, and I'm going to say reveal seed phrase. Now it's going to have me enter a password here. And now this is what the seed phrase looks like. It's basically just 12 words, I think. 12
11.
words, 11 words. This gives you access to 12. It gives you access to the entire wallet, and all of the, you can actually create multiple wallets off of this. So this is crazy important for you to protect. Some people don't even write it to their disk because they're, even if you delete the file, people can try to find it if it's not properly overwritten. So just keep that in mind. I know I'm kind of beating a dead horse, but just, it's really important. So I'm going to copy this, and now I'm going to use this in this code base. So I'm going to go ahead and create a new file. I'm just going to right click here and say new file, and I'm going to call it .secret. Now on the .secret file, I'm going to paste those 12 words. Now with that in place, this code can load up that file into this variable. This variable, after this executes, is going to have those 12 words inside of it. And now down here, we have this little networks block that allows us to define different networks that we can deploy to. This code base right now has a development network, which we can run on our local host, which we're currently not running, the RINC-B network, and the Gorelli network. Now, typically, you'd probably want to run a full node yourself, but that's a whole nother topic in itself, which maybe we can go into in the future. We're not doing that here. We're using a service called Infura. Now, Infura is basically just a hosted node service. So they're running Ethereum nodes that we can actually connect to from our code. Look at that, like makes me look orange. So we're just using this. This is for the level that we're using. It's a free service. I think they're charging for some services here, but we're just connecting to it right here using this HD wallet provider object. And we're giving it our mnemonic, and we're going out and connecting to this address. I had to create an app on it and get a key and all that type of stuff. So that's already preloaded in these environments. So you don't have to worry about that. We also give it a network ID, which each one of these has a network ID. So Gorelli is naturally 5. And we give it some predefined gas. Now we can go into a lot of the aspects of how do you calculate the amount of gas you're going to use, kind of going back to this. You know, there are calculators out there for you to calculate. You paste in your bytecode or your contract code, and it tells you how much gas you're going to need to actually be able to deploy that contract. This is, I think, pretty default values for this test net. So that should get us up there to the network. So Maureen, you have I saw you raised your hand there. You got a question?
Yeah, I actually do have a question.
Sure.
Sorry. Can you define the amount of gas as a formula instead of actual value?
Absolutely. So you can. So there are utilities. Web3.js specifically has a bunch of different different functions you can call. And I think the actual Ethereum nodes themselves, if it's exposing what's called the RPC API, there are calls that you can make that basically says estimate gas, right? So you call into estimate gas, you give it some bytecode, and it'll return back to you what the gas would be for it. And typically, that's a great question. Typically, I think that's how you would do it in a more of a production environment. You'd want to estimate your gas before you try to do this transaction, because you want to make sure that you are putting up the right amount of gas. Because if you're not, you're gonna lose money doing that. If you go into the mainnet, if you don't have enough, it's gonna fail, and you're gonna lose the gas that you've spent already. So you don't want to be doing that over and over again if you're trying to deploy to the mainnet. Okay, so now with all of that in place, right? So we have our contract, we have our truffle configuration. Now what we can do is on the terminal itself, we have our secret with our mnemonic in there. Now we can actually use truffle to deploy to the test net. And now we could type this. We can actually just type, if we want to just compile our contracts, we could just type truffle compile. And that's going to go out there. It's going to grab Sol C, which is the compiler we're going to use. And it's fetching Sol C, and then it's going to compile all the contracts that we need to deploy. And then boom, it compiled it. Now it's going to create a build directory, and this build directory is going to contain these JSON files, which are what's called the application binary interface into the contracts themselves. I'm not going to go crazy into that. This is for users of the actual contracts that they can use to actually call into the contracts we deploy. Being that we're using ERC20, it's a standard interface. So Metamask already knows how to consume these interfaces, which is awesome, right? One of the benefits of using these kind of shared standards. So with the contracts compiled and ready to go, we can now migrate them to the actual networks themselves. So let's go ahead and do that. I'm going to say truffle migrate, and now we're going to give it a network of Gorelli. And I think I have to say network Gorelli.
Where did you name it?
So it's named inside of this truffle config file right here. So now what this is going to try to do is it's going to go out there, it's going to compile the contracts, then it's going to go and try to deploy to the blockchain. So you can see it's deploying. Here's a transaction hash. We can actually go to Etherscan while that's doing its thing.
Post that into the chat, please.
Yeah, here's the transaction hash. And how do I switch the network I'm on? Here we go. Gorelli. Okay, so it's saying transaction will be included in this block number and we reflect it in a short while. You can go back here. You can still see it's waiting. Again, Gorelli, every, I think, 12 seconds, a block is mined. So we're going to have to wait over 12 seconds. So we're waiting. And you can see here, it read the balance of the wallet because we gave it the mnemonic that has that balance in it. And then boom, here we go. So now we have a contract address right here.
That's the address on it.
Yeah, here's the contract address. I'm gonna put it in the chat here. And you can see that it cost 0.01 ETH to deploy this contract. That was the total cost. Truffle's pretty nice. It gives you a nice little report of how you how much it cost, how long it took. It gives you a whole bunch of information there. Boom, there we go. So we did 2 deployments. We actually had another contract in there, a little test contract called migrations, and then the total, the my token. And there we go. But you know what? I just realized we just deployed this, but I missed a really critical part of this. So there's a part that I need to show before we actually look at that contract. I'll keep that deployed. That worked. But remember I said this is just a template? We didn't actually name anything yet here. So I need to show you another concept here called migrations. And this is all JavaScript. It's super simple JavaScript called deploy token. This is where we are using some of the actual Solidity code in the form of an interface to be able to say, hey, what is the name of the token? What is the symbol? And what are the decimals? And then we're calling this deploy function on it. So when I just did that call right here, when I said truffle migrate, I was using the code in here along with the code in the truffle config to be able to deploy this token. So it read this and said, hey, these are the variables that we want to change. We want to call it Long Island blockchain token, LIBC, have 18 decimals, and then we're going to go ahead and deploy that token. And this right here where it says my token is the link to the Solidity code. That's where it's really using this JSON file here, this one specifically, to be able to create that interface so that we can deploy the contract.
How many coins did you create?
Good question. So I just created 10,000 coins.
Okay, I got you.
Metamask isn't recognizing it. So can you make sure where it was went to?
Yeah, so now this is all well and good, and I'm sure a lot of you guys are like cross-eyed by now. Like it's almost 10 o'clock, and this guy is just going. So we now have this contract address, right? Now, how do we actually see that it worked? So if we go back to MetaMask, again, this MetaMask wallet is the same one we used in this code. and we click this button, add token, and then we go to custom token, and we post this address right here, the contract address. Notice how it filled this out automatically. So the symbol is LIBC and the decimal precision is 18. Then if I click next, oh, there's none there. Let's see.
I don't know where you put it, sent them to.
Huh. That's weird. Bomp, bomp. So that should have deployed there. Costs, did my ETH go down?
It did.
It did.
Yeah, you
So-
deployed it. You just may have sent it to maybe your old wallet.
No, I didn't send it to my old wallet because I just took the seed from there. I think maybe got to make this larger. Maybe this isn't working here. Let's see. Let's try it again. Now, I guess this is a good example. If we go ahead and let's mint a bunch more. All right. And let's go right here and say truffle compile. Okay. You know what? I'm going to go into bash because I could go up. Truffle migrate equal Gorelli. Now, this is interesting too, because now I'm migrating this again, and it's basically going to create a new contract. So it's going to get a new contract address, and it's going to be called the same. Oh, no, it doesn't. See, this has happened before with me where it's, if I change this, I'm going to change this to LIBC2.
Do you have to compile again?
I think I do. Let's see.
Oh, it does it for you. That's cool. No?
Yeah, but it's seeing it, everything is up to date. That's not right. So this secret is there. The LIBC token.
While he's doing that, you guys should check out Bomb token. That's a token too. It's more deflationary than Bitcoin.
More deflationary. So almost half every 2 years.
Well, I'm not sure what Bitcoin has, but Bomb coin is like every time you do a transaction like off the exchange or whatever, it burns 1% of the coin, and there's only 1 million ever created. It's a social coin. It's kind of like what he's doing now. It's an ERC20 token. It has value. It's around $1 right now.
I'm already totally confused. Can we just keep it to this little thing right here? Jesus. I'm sorry. I'm like trying to follow, and I don't. I need.
There's a lot going on right now, and I don't blame you. There's a lot here. There's a lot to digest, so it's definitely not simple. And I don't know if we're gonna get this, guys. So I don't know if this is. Oh, you know what?
I was good. I was with you, and then I kind of then I'm like, all right, let me look now. Look hard at this, and I'm like, okay. No, it was good though. This was more than I knew way before, so this is okay. But I have to admit now, I'm getting a little lost.
Well, that's because it's broken.
It's called cessation. When you get too much going on in your head, it starts to get swishy.
Yeah. That makes a lot of sense. Let's see if this next migration works. If this doesn't work, then we'll it's not a big deal. Basically, when it does work, you're going to see this value instead of saying 0, it's going to say 10,000. And the key point there is that you can send this around now, just like you can with Ether. So, we can send this to people anywhere on the network, which is powerful, right? So we can do other things with this. And I think that's what kind of Craig mentioned in the beginning, was experimenting with this idea a little bit in our community to see what we can do and just pass this around, even if it's just on the test net, right? Because we don't want this to cost real money right now. We're just experimenting. So, playing around on the testnet and saying, hey, if you have 10 LIBC, you can access this other piece of functionality. And you know what? That's something I can show off before we end here. While this is saving, and I think this will be a good icing on the cake for some of the technical stuff we did here. So if we look at this, let's see if this contract address has anything in it.
So if you go to your MetaMask and you put in LIBC and add a token, it should show up.
Yeah, so this is still 0. I'm not sure why that's happening. We'll have to follow up with that. But yes, exactly. So one way we can show this off is, and this is another topic that we'd like to cover, is a lot of that stuff was super technical and probably spun a lot of heads, but it could come down to this. And this is something I built recently just to experiment with creating your own coin without having to know any of what we just showed off. So this is a createcoin.surge. I'll go ahead and push this in the chat, and pretty confident this one will work. So this is doing client-side compilation of a contract and then deploying it. So if I say connect wallet, MetaMask is going to come up and say, what account do you want to connect with? I'm going to connect here. And you could do this with any wallet. The web service itself does not see any information besides your public address. You could give it a coin, say, let's call it Long Island blockchain. I could type. And I'll call it LIBC. Now I'll go ahead and click create coin. This is going to go out and say, hey, you're trying to deploy a contract, confirm it. It's going to do that gas calculation for you. And you could say confirm. It's going to send a transaction out to the network, which doing it this way is kind of nice because it's fully integrated into MetaMask. So you can see that there's a contract deployment pending. You can click on it. It'll link out right to Etherscan. So you can see that this is happening on the public blockchain on Etherscan. It's waiting for the contract creation to take place. And once that 11 or something seconds or a couple of blocks get mined, it should return to us an address. There we go. So now we have a contract address. I can copy that. I'm going to do the same thing that we just did with all the code stuff. I'm going to say add token, custom token, contract address, and boom. This case, I went to the extreme. I minted 100 million tokens. Ha ha ha.
Now that's cool.
Nice.
No, but you know what? This totally made more sense. I mean, now I understood everything that you just did, basically. You know what I mean? Like,
beautiful.
Yeah, no, it made me conceptualize everything that we just did.
Excellent. That's good to hear. Yeah, this really is kind of like the front facing of everything we just looked at.
And so all these cool tools, Nick, you could actually hide this on our website. So if you have 0 LIBC coins, you won't see this little applet. But if you have whatever the minimum is, 1 million LIBC coins, then this applet will be available and you can use it because you're connected to MetaMask and MetaMask recognize you have the minimum required LIBC coins to see this component.
Yep. Yeah, cool.
Is this like an active program? Is that the right word? Like,
Yep. The cool thing about this is it's all client-side code. So I could connect to the mainnet and use this code, use this website, and it's all client-side, which means that there's nothing you're sending to a server. It's all just delivered to your browser, and everything is on your computer. So
no API?
Nope.
Ah.
Yeah.
It is the API.
Right, right. Gotcha. This is dope. I want this.
Awesome.
Me too. This is exactly what I told Nick we needed to build last time we ran this event.
Yep.
Yeah, no, this is yeah. After you show like all the steps, all the text and whatever, then you show this and you're like, boom, this is what this is. And this is how you would get to this place. Yeah, this is totally, I like this, guys. Thank you. I like this.
Awesome. Thanks, Tiffany. I'm glad to hear.
So we're going to figure out what happened on the other contract. We are going to host another event, probably one that'll show off the front end so that we can reference back to, hey, we did the technicals. It didn't work, but let's assume it did. And, you can look a little bit at the technicals here, and here's an event that we'll probably speculate and create a bunch of coins and play. Yeah.
Question, I have my, I have the MetaMask wallet, and I'm looking in here and it says add tokens. If I click that and I put in LIBC, will that
I
token
give him
show?
that bottom contract, the one that ends in E945. Nick?
So this one?
If I go in my thing, it says here buy ETH, or it says or add tokens,
Yeah, so Tom, you'll want to add token.
right?
Nick could demonstrate. You do custom token, and paste in the contract address that Nick has highlighted. Nick, you want to, there it is.
Address.
And then you will see the million tokens.
Yep. Now you have to make sure that you imported that mnemonic that we had before, because that gives you access. Because the wallet right here.
Yeah, I have this wallet.
Oh, $4 whatever.
Yeah. So if you want, I can say, if you don't have that wallet imported, which I'm thinking you probably don't, post your address into the chat and I'll send you a bunch of these LIBC and you can see them transfer over.
Okay. I think I responded to your email, Craig.
My
My MetaMask receiving address or something like that.
Did you put, when you say you responded to my email, you mean the
You
Google?
sent one out the other day.
Oh yeah, let me see.
It's something about if you want to participate and you want us to send you a little bit of ETH. I mean, a little bit.
Let me see. Created your own crypto coin, responses.
So Vic, I got your message there. I'm going to go ahead and send you some. Send you. I won't be stingy because I have 100 million, so I'll send you 1,000.
And here you go. Here is Tom's.
You're
wallet
rich.
address.
You know what? I'm feeling real. I'm going to send you 10,000.
Hey.
Hey, Craig, I sent you my wallet address in a direct chat text because I didn't want to put it on the record.
Yeah, I'll send it to Nick privately here so that he has it. But so the concept, you actually do want to share this wallet address. This is one of those wallet addresses that nobody can authorize it, but people can send you money. There's no reason to really protect it.
Yeah.
Okay.
But to alleviate your concerns, I'll still send it to him privately.
Thank you. Now, when you check on Etherscan to check the address, will they be able to see that address? Like, does that show up on the Etherscan address?
Yes.
Yeah.
Okay. So that's why I would do it, because I wouldn't want anyone to track that address and kind of like,
yeah, how much you got, what your balance is and shit. Yeah, that makes sense.
Okay.
So I'm just doling out 10,000 LIBC all over the place here. So if you guys posted the address in there, Vignesh, I got you. Vladen, I got you. Craig, I'm sending you now.
And I'm sending you on Slack. Private message.
I'm still a little lost here.
It's all right. It's all right. So somebody did ask here, Masha, and I apologize if I'm hacking people's names here. What are some good advice for folks starting out with some of this stuff? And that's a great question. I wish I had a great answer for that. There are a lot of different forums, depending on where there's so many places to kind of dip into. Like if you're just purely on the investing side or on the development side, and there's a lot of in between. So I guess it really depends on where you're looking to attack this from. I tend to be a little bit more into the technology. I want to understand how this is going to change the financial.
I tend to be more into the degenerative kitties and other nonsense.
Yeah, but I think an easy answer to that is just do what you're doing right here. Get involved with these communities. We're trying to build this more on Long Island here, just to get folks together and to learn together. And I think that's a great step forward for that.
Yeah, I mean, there's a couple of TED Talks or other things that are just for overall blockchain beginnings. In fact, my favorite is, what's his name?
Andreas Antonopoulos is a good guy to start with.
That's a good one.
He has the Internet of Money, or yeah. Andreas Antonopoulos. Start with
Don Tapscott. That one's my favorite.
Andreas
If
Antonopoulos.
you've ever seen Don Tapscott's
whom else? You
talk.
can also check out like the history of
Antonopoulos is he hosts a podcast. I mean, that's where I do most of my learning is through podcasts. But
yeah. He's is anyone on Clubhouse?
You know what? I haven't signed up yet. I keep hearing it. I'm almost scared to sign up. Like, is it just like you get dumped into a chat room and you're talking to them?
No, you guys would do so well. You could have your Long Island blockchain Clubhouse. And under that, you would have like different rooms that talked about like making tokens or what is blockchain and, blockchain for beginners. It's just such an open space. Like, I have an invite that I could send to you if you have an iPhone. It's only on beta. It's in beta right now on the iPhone.
Oh, I would
You have
love
to
that.
be invited to it.
I'm gonna send you need my cell phone number for that.
Yeah.
All right, there it is in the chat. I would love an invite. I've been hearing about it and I tried to sign up, but I saw that it was invite only.
Yeah, I have one for you. And like once you go, I will I'll make a room for you, like a party room. And it's kind of like a welcome, right? And you can invite people or whomever, whatever, and then you can just start on your way. You do 3 rooms and you can qualify for a clubhouse. And then once the the administrators accept it, then you're able to host like certain things. And like you must get on there now. Like it's just like a totally interesting place. And then we can like link up and have like cross chains of like different rooms. I have like a room right now where I talk about the metaphysics of the blockchain.
Interesting. Okay.
And there's other rooms with people who are like shilling their stuff. There's this guy who has Swan coin or like a Swan something. It's a wallet where you can do dollar cost averaging on it. And he's like always talking it. It's like this really cool place. I would sit and look around for like a couple of days, do like the beginner class. There's like a beginner intro class so you can know about all the functionality and all the rules and all that stuff, and then like go for it. Like it's a podcast type of situation where you can make a group and do all of this. The only thing is that it's not visual, right? So all of it is kind of like, but you can like connect it to your Instagram or your Twitter. So you make a Long Island blockchain Twitter account or whatever, or an Instagram account for the group, and then you can be able to post things there and stuff. It's really cool.
Awesome.
I'm gonna get your number right now and send you a invite.
Nice. Yeah, I appreciate it. That'd be awesome.
Yeah. You guys are awesome. I really appreciate you guys taking out the time to do this, even though but you did say this, we don't know if this is going to work right now. And this is kind of unorthodox, this whole thing.
We were hoping it would.
Yeah. We tested it like a million times.
We'll try it again.
Yeah.
I'm fairly confident, Nick. It's because we changed the wallet.
Probably. Yeah.
Okay.
Well, we'll figure it out. We're gonna post this recording to our website. The website is liblockchain.org. We're not really doing much with it right now, but we figured have some place that's.
Any web designers that want to help, we'll send out even more LIBC coin.
Yeah, that's great. When do you plan on having the next meetup?
It's a good question. I don't think, we're probably not going to do this monthly on any set like cadence schedule just yet. But we would like to do a fair amount of them this year. Last year, we kind of went dry with it, just considering the year, we didn't really know what to do. And I'd like to do more. So if you guys have any topics that you want to talk about, I can definitely come up with a bunch of different topics. Most of my topics are going to be pretty technical. I'd love to go into the front end. I'd love to go into different contract types. There's a ton I'd love to explore with you guys. But I don't want to make it just kind of like every month, Nick's going to be out there talking about stuff. Like I'd love to kind of make a community about this and get other folks
So the answer to the question is we'll probably look to do something soon, just to kind of build on what we did. And then if we don't, if it doesn't gain traction, then it'll probably slow. And if it does gain traction, and if you guys are interested and join us, it'll probably rejuvenate us and host more events.
Yeah.
Honestly,
Well, I'll stick around.
the more you want to learn, the more you want to give us topics on, the more that we'll go do enough of the research so that we can, have that open conversation.
That's great. That's great. No, I appreciate, I'm just jumping on, guys. I was listening throughout the whole call, but now I'm actually in the mix here. So I'm actually part of the Boston Blockchain Association. So we can definitely connect because we're always looking for people to just help out with events, have an open source community where other hackers and coders can come in and learn about blockchain and make tokens, so on and so forth. So let's connect on LinkedIn. I'll drop it here.
Yeah, awesome. That's great. Yeah. That's great. We love that. Beautiful. Cool.
So we went, Nick and I wrote an agenda. It took us to 9:15 and we clearly blew it out of
the water. Yeah.
Thank you, everyone. We really appreciate your time. Next time it'll work. And yeah, we'll get it going.
So one last question.
Please.
If you had $1,000 to invest in a coin, where would you go?
I wouldn't give any answer other than Ethereum. Now, really cool.
No, it's funny because people know that I've been dabbling in this now for going on a couple of years, and now they're starting to hear more about it. They're always asking me, "Oh, what do you do?" First thing I say is, don't invest anything you can't afford to lose. That's one. Second is stick with the big guys. Stick with the big guys.
If I had
Bitcoin, Ethereum, just
if I had not
when you start dabbling
crypto kitties and other stupid degenerative things that I've done, my crypto wealth would have been significantly higher.
If you just stuck with the big guys.
If I stayed consolidated and let it, the market always works, and there's a couple big days where the market really cranks out your wallet, and if you miss those, you miss. So to that point, yes, stick with the blue chips. I would definitely look at Ethereum staking capabilities. So even if you have less than 32, there's a tremendous amount of services that'll let you start staking with any value of Ethereum.
Now, if you stake with Ethereum, don't you have to leave it on there for at least 2 years if you lose control of it?
Lose control of it, but yeah, when you deposit on the Beacon chain right now, it will be locked for about 2 years. If you deposit on some of the services that are offering ETH2 staking, it is not locked up, because basically what you're doing is you're providing liquidity to these services, and they are doing the actual staking. So they'll allow you to be liquid, but they're going to charge you a fee to do the hosting service.
Okay.
So it sounds like you're finally getting paid to have your coins in a hot wallet on an exchange. And if I had $1,000, I would buy Nexo coin. It's a small coin, but it has utility. And not only that they're doing a buyback right now, but it's a restricted security though. Just keep that in mind.
Restricted security, what does that mean? You can't get
like for the US, you would have to hold it for 1 year.
Oh, okay.
Hey, Nick, can you check your iPhone, see if you got a text message?
Sure. Not yet.
Nobody else, huh?
Yeah, I mean, I'm definitely a long-term blue chip holder. Like I there's really not a lot of alts that I'm very interested in. Ethereum and Bitcoin has been my mainstay for a long time, and that's I like some of the DeFi stuff too. Like I converted some into DAI, and I'm putting it up on Yearn Finance and getting a nice little percentage on that. Nice little percentage, like triple the amount a bank would give you, but it's
more than triple, significantly more than triple. Tiffany sent it to me. Oops.
Oh,
you just have to be very careful. I mean,
oops.
Yeah, this is me.
Dump out there,
What was that?
There's a lot of pump and dump, people pump up a coin and then they, that's why like somebody gives you sort of like somebody giving you a stock tip. Oh, you got to try this stock. Stick with the big guys.
Yeah.
That's why you get it early, just like in Bitcoin. If you got it early, you're not worried about anything. But if it's so early, if you can get some of these early, you don't worry about it.
Right.
Yeah.
If you buy like 0.009 cents or something and it goes up to $1, you did good.
Right.
But I'm not more into technical. I'm more into the investment. That's why I'm asking.
Cool.
So maybe
For indexes.
Huh?
If I weren't going to tell you to invest in Ethereum for $1,000, I would tell you to invest in something called DeFi Index. It is an index of the top decentralized finance coins.
Really? Huh? DeFi, it's like a blend.
It's a blend.
Where do you find that?
Tokensets.com.
Go check it out.
It's like a mutual fund then.
Yeah, it's like a new school mutual fund.
Yes.
Yeah,
Indexes are a nice, easy way so that you're not sitting there trying to, cherry pick a bunch of winners.
Yeah.
I to be honest with you, I seem to, instead of, I like to look at who the creators of the coins are.
What's crazy is a lot of the really crazy degenerative finance guys, they stay anonymous and they get to because it's all in the code. You don't have to know or trust me. A lot of these developers just have to know or trust how to read the code. And if you read the code and it, and it does certain transactions, they'll participate. But they stay anonymous. But to your point, that's why I believed in Ethereum and
Yeah.
I had an opportunity to listen to Vitalik and understand his brilliance.
We met him like what 2 years ago now.
What's he like about? He's something years old now.
Yeah, he's like mega young.
He's 21 or 22. He's like 9 feet tall.
We were total fanboys too. Like we selfie, like it's funny.
Yeah.
What is your opinion on a Hedra hash graph? I'm pretty invested into that coin myself.
I don't know enough about it, but I've seen across the market that it has a lot of respect. But I don't know how I don't know enough about its consensus mechanism.
Right. So it's a decentralized ledger. It functions like a blockchain, but I got to definitely brush up on its intricacies because they're very similar and the transaction speeds are really fast when it comes to, OTC methods and stuff like that, people buying through a broker or over the counter or just buying a token, things of that, so the transaction speeds are like a fraction of a second.
Interesting.
Quick question, Nick 2 cents. Does that sound familiar?
Nick 2 cents?
Yeah,
No.
I hope I don't want to invite somebody that I.
No, I didn't get it.
Mike got Nick's invite. Is that what just happened?
Yes, I think so.
Okay. So when Mike gets in, he's gonna have 2 invites, and just invite Nick.
Cool. Yeah, that'd be awesome, Mike.
Gonna cost
you up to that task.
Looking at the wrong thing.
LIDC.
That's all good.
Cool.
All right, guys. So I think we'll end there. We're almost at 10:30. Again, we did record this, so we will post this to the website.
And the meetup.
And the meetup, and the meetup. We're all on the meetup and looking forward to doing this again. If you guys have any time, I just got a text for Clubhouse. Awesome.
All right, I got it. So yeah,
Cool.
that was another person I had on my phone. I didn't want to send it because you only get a certain amount. So like.
Yeah. Cool. Appreciate it.
Yeah, no problem.
Thank you very much, guys. Picked up a few points, but it's still a little outside my realm, but still picked up some points.
Cool. Awesome. Well, thanks for coming tonight. Thanks for spending the time tonight with us. And we look forward to doing more in the future and continuing to learn.
Yes,
Nick.
All right.
Hit me up on Clubhouse, guys.
Cool. He talked to you on
See you
Clubhouse.
there.
Thanks.
Get an apple, though.
I'll make a party for you and show you around.
Awesome.
All right.
Thank you.
You guys crushed it. You knocked it
Yeah,
out.
you did very
It was
well.
excellent.
Thanks,
Very,
guys.
very
Thank
good
you.
educator, and I'm excited for future webinars that you guys host. So it's gonna be great.
Awesome.
Yeah.
Thanks, man.
Vlad, I just reached out on LinkedIn. Let's see how we can collaborate.
Perfect. Let's do it. I'll hit you up on LinkedIn.
Awesome.
Take
Have a
care,
good
everyone. Bye.
See you guys later.
Okay. Good night. Bye
Good
bye.
night. I'll talk to you in the morning, Vic.
All right. Good night, Mike.
Good night.
Yeah.
Bye.